Hey guys, in this video I wanted to take an SBAC question like this that I think offers a pretty good opportunity to show some animation and some simulation kind of mathematically, I guess, and answer this type of question. So this just says that you have an insect that's flying back and forth, and the graph shows the insect's distance in meters from its starting point as a function of time in seconds. And they're supposed to drag the little gold star that's up here on the SBAC test and this little red diamond. The gold star marks the insect is at its greatest distance from the starting point, so I would put the gold star right there, and then drag the red diamond on the curve where it's returning back to its starting point, which I would imagine would be right there, right? Because its distance is going to be 0. So here is our curve, and we can have a point maybe on GeoGebra represent the fly. You know, if you wanted to get creative, you could even get a little fly picture and make that the point. But if we had a point, we could actually have it model this curve right here, right? So what we should do, this would be more of a advanced algebra, pre-calculus maybe concept here. I'm going to grab this picture. Let's do a regression. Let's actually have GeoGebra take some of these key points basically and have it create some kind of polynomial that will map this out. And then we can just do some kind of animation with a point as it follows the curve. So we know that looking at the graph here, that 0, 0 is definitely a point. Looking at the number of turns, right, there's 1 turn, 2 turn, 3 turns. So this has to be at least a 4th degree polynomial, if I remember that correctly. I could be wrong, but I think that's going to be at least a 4th degree polynomial. So to come up with, to do a regression for an equation, we're going to need, I believe, one more point than the degree to come up with an equation. So let's come up with some of these key points or something that's really close to this so that we can get that idea of simulating here. So what we need to do is approximate at least 5 points. So some of these key points here, like right here, looks like we have the point, I'm going to call that 8 3/4. So maybe 8.750 is a second point we can say. Maybe this point right here looks like 7.5. Right? Looks pretty close. Maybe this point here is at 4, and if I go straight out, 2.5, we'll call it. 4, 2.5. All right, there's 4 points. Let's get a 5th point. Maybe this one here. We can call that 1.5 and 3.2, something like that, right? 1.5. I'm just approximating. We'll call it 3.2. So there's our 5 points. So let's go ahead and put those into GeoGebra. So I'm going to come in GeoGebra. I'm going to view my spreadsheet. And I'm not going to make this fancy. We are going to put in a 0, and we get out a 0. Right? The next point that we said is, let's put in 1.5, 3.2. Let's put in 4, 2.5, or an input of 4, get out of 2.5. 7.5. And then 8.750, where that red diamond would go. Okay, so here's our 5 points. Let's just go ahead and highlight all our data, and let's do a regression. So let's do we can plot the points if we wanted to. Let's go ahead and just do that real quick. So here's our points. I'm going to hit create. There's our curve, right? And if we put our axes and our grid lines on there, those are the points that we have here, right? And so now I'm going to re-highlight these, and let's go to the 2 variable regression analysis like I used in the previous video here. So since we have 2 variables, let's do that. Let's make sure that these are right. So this looks just like that table. So let's analyze it. And now we're talking about a polynomial, and let's set it to a 4th degree. And then there's that curve, right? So that looks pretty awesome right there. I keep hesitating because I know that there's a feature here that allows us to put this equation in GeoGebra here. So what is our regression? Where's our equation at here? Okay, sorry, I just paused the video. I'm sure you watching this had no idea I just did that. But I paused the video, and I got my equation to come up here. Here's our 4th degree polynomial. And I figured out how to get the curve and the equation, the function, into our GeoGebra screen, which is this icon right here with that little arrow going out. And we can copy to graphics view. And there we go, we got our function defined as our regression model, and it puts the curve right through our points there. Perfect. Now we've got the graph, we've got the fly's path. So incredible math conversations depending on what level again you want to get to. And let's go ahead and talk about simulation maybe. So what we can do is let's create a slider that's going to slide our input value, right? We'll call it X this time, or F for fly, or whatever you want to call it. And we're only going from 0, and our max is going to be what we define to be 8.75, and then our interval can jump whatever we want it to. Since this is going to be an animation, maybe 0.05, right? Something pretty small for a jump, and you'll see why, I think. So, can't call it X. It's just going to define it as A, and that's okay. So now what we can do is let's put a point that'll slide dependent on our slider here. That will just follow this curve. So to do that, I'm going to put my ordered pair. My X coordinate is going to be whatever A is. Since our function is defined as g of x up here in the algebra window, then I'm going to just put in g of A. And so there's our point. Let's make it stand out here. Let's make it weird. Okay, here's our fly, and we'll just make him green. Okay, so now as we slide A around, we can see that this point will just stay on our curve, right? And this is a great way to do an evaluation tool on a function also. You can look at a whole bunch of different evaluations. So here's our fly. You know, one thing we can look at is the distance. We can put a vertical segment that'll go along with this and have it record the distance if we wanted it to. Or if I just right-click my slider, I can go to animation on, and it'll go ahead and animate our fly for us. Okay. When you do an animation, there's going to be this little pause play button down here, so you can always pause it, and we can change some things if we wanted to. Maybe our fly is moving too slow. So I'm going to go to the object properties of my slider. So right-click my slider, go to the object properties. Waiting for my slow tablet to do something. Here we go. So now it's going to oscillate this animation here at a speed of 1. Maybe I want this to be faster, so I'll go with speed of 4. Oscillating means when the slider gets to the end, the value is just going to come back and slide this way, then just oscillate back and forth. You can do an increasing one where it hits the end of the slider and jumps right to the beginning and just continues to increase. But since this is a fly flying back and forth, I think that we're good here. So now when we go ahead and hit play, our fly is moving a little bit faster, and we can see that it's just going to oscillate back and forth here. And we can ask the question of how far is, where's its furthest point from the x-axis, if that's what we wanted to do. So a video here to show you, again, some regression capabilities, a little simulation, and a little animation of a fly oscillating here. So I think this would be a great example too, if you had students do this all and learn that, that this point, there's a lot of math behind that point as far as how we teach in high school math, function notation, and then this slider just adds some incredible visual capabilities of GeoGebra. So I hope that made some sense, guys. Please give me any comments or concerns with this. Thank you.